All right, we're going to do a quick review here of trig identities. So I'm on page 188 to start with. So far we've looked at we've talked about sine x, cos x, tan x, okay? And then secant x, cotan x, okay? In which secant x is 1 over sine x, secant x is 1 over cos x, and cotan x is 1 over tan x, or cos x over sine x, okay? Now, what we are going to look at is, it says reciprocal quotient and Pythagorean identities. Okay, now, an identity allows us to change the form of an equation so that it helps us solve, all right? So the only way that I can really show you how this makes sense to you, or right away, or how it's going to make sense to you, is we have studied the unit circle and we've looked at all the 30-degree angles around the circle. We've looked at all the 45s around the circle, the 90s around the circle, and we know all of the identities. Okay, we know all of the identities that, all of the exact values of those going around the circle. But what happens if I don't know the exact value of something? Like, for example, the sine of 15 degrees. And I want to find out what the sine of 15 degrees is. Well, there must be a way in which I can get sine of 15, an exact value of it, but I need to use what we call an identity in order to do that. So I would change this to, now don't write this down, don't pay much attention to this. I could change this to sine 45 minus 30 degrees, because that's what 15 is, because I know the 45 and 30. And then the identity for it is what we call a difference identity, which is sine 45, what is it, sine cos, yeah, sine cos 30, subtract, or add, I can't remember what this identity is offhand, sine 30, cos 45. So anyways, the long and short of it is this. I have to change sine 15 into something that I can work with based on this, and I have to use what I call an identity, okay? So I'm just going to erase this out right now. And I'm going to establish a couple more identities. Now, on your formula sheet for your exam, you will be given a few of these identities. Now, the very first identity that you know about is the Pythagorean identity, and that is this. Oops. I'm going to do this different because it cos squared theta plus sine squared theta is equal to 1. Okay? That's an identity. We know that if we take any angle on the unit circle, for example, let's take 30 degrees, and let's prove this as an identity. Now, an identity has an equal sign in it, but we don't treat it as an equal sign. We treat it as the left side has to equal the right side, all right? Or has to be the same as. That might be a better way of describing it. So let's take this particular equation, and I want it to equal both sides. Now, the one major difference that we're going to do is we are not going to work on both sides of the equal sign. All right, we are going to work on one side and prove that one side equals the other side. Now, there is situations in which you can work on both sides to make it easier, but this is how we're going to do it. So the first way we're going to do it is we're going to choose an angle, substitute that angle in, and then prove that the left side equals the right side. So for example, I'm going to say theta is equal to 30 degrees. So I put cos squared theta, so cos squared of 30 degrees. Well, the cos value of 30 degrees is root 3 over 2 squared, plus the sine value of 30 degrees is 1/2, and we square it. So let's keep working on it. We're going to simplify the left side. So this squared gives me 3 over 4 plus 1 over 4. So 3/4 plus 1/4 is equal to 1. 1 is equal to my right-hand side. So what I've done is I've taken this identity of cos squared plus sine squared equaling 1. I've used an angle and the exact values that I know off the unit circle, and I've proved that cos squared plus sine squared is equal to 1. Cos of 30 degrees is root 3 over 2 squared plus 1/2 squared. 3/4 plus 1/4 equals 1. Now, it doesn't matter which angle I pick on the unit circle. It's always going to work out so that sine squared, cos squared plus sine squared is equal to 1. All right? This is what we call a Pythagorean identity. Now, I'm going to create 2 more Pythagorean identities out of this. Now, I know the word identity is what really throws students for a loop, but all it is an expression that is used to make something simpler to solve a question. All right, so I'm going to start with this again, and I'm going to go cos squared theta plus sine squared theta is equal to 1. And now what I'm going to do is I'm going to create 2 more identities. The first identity is going to be created by dividing everything by cos squared theta. All right, cos squared theta divided by cos squared theta is 1 plus sine squared theta divided by cos squared theta. That is tan squared theta. And then that's secant squared theta. So this is identity number 2. So what I suggest you do as we get going through this, because we're going to use our basic 6 trig identities, so sine, cos, tan, cosecant, secant, and cotangent. We're going to use cos squared plus sine squared theta equals 1. 1 plus tan squared is equal to secant squared theta. And then the next one is I do this again, except this time I'm going to divide everything by sine squared theta. And I end up with cotan squared theta plus 1 is equal to cosecant squared theta. And again, these identities are going to be used to make life simpler when it comes to solving equations and finding exact values of angles. All right? So what I would suggest for this unit is, number 1 is I would go online and I would find the formula sheet that's given for the exam, for the pre-calculus exam. All right? Or I would write down the equation. So I would go into the book and I would write out all of these identities as we go through. Now we're going to get sum and difference identities, and we're going to get half angle identities. So there's going to be a number of them that we're going to get, but it's easier to work with them as long as they're right beside you. Okay. So the first thing I'm going to look at is page 189. So working example 1, it says determine the non-permissible value in degrees for the equation cosecant theta equals cotan theta over cos theta. All right, I'm going to start with something a little bit simpler than this. First of all, the non-permissible values, to refresh, the non-permissible values are when you have a fraction. If I had 1 over sine theta, so basically cosecant theta, if I had 1 over sine theta, sine theta cannot equal 0. So now what we have to do is we have to go through and we have to find all the values on the unit circle in which sine theta can equal 0. Well, where is sine theta equal to 0? At 0 degrees and 180 degrees, right? So 0 degrees, 180 degrees. Then I would do 360 degrees, and so on as I go through the circle. So the non-permissible values in degrees for the equation, for this equation, would be all of this. Now that's for 1 rotation around the circle. I may have to explain it in terms of, all right, I just got to think this through here. Would be k times 180 degrees. Whoops. So for every 180 degrees, where k is an integer, where k is an integer. Okay? So this would explain every time I go 180 degrees, I'm going to end up with sine theta equaling 0. This would be a restriction on my graph, or a non-permissible value. Numerically and graphically. Well, we're going to not focus on the graphing part just yet. All right? The graphing part we'll look at as we get down. So it says determine the non-permissible values in degrees for the equation. So my equation is this. Cosecant theta equals cotan theta over cos theta. Okay, so all of the non-permissible. Well, cosecant theta is equal to 1 over sine. So I'm just going to switch these out a little bit into their basic. So that's 1 over sine. Okay, cotan theta is cos theta over sine theta. And all that's over cos theta. So you can see I have a number of denominators here. So for this question, sine theta can't equal 0. And cos theta also cannot equal 0. So for what angle does sine theta equal 0? Well, we just finished going through this. 0 degrees, 180 degrees, 360 degrees. For what angle does cos theta not equal 0? Whoops. This should be can equals and equals 90 degrees, 270 degrees. So if I'm going once around the circle, basically what I'm saying is theta can't be 0, 90, 180, 270, or 360, or I would have a non-permissible value. Okay? Now, I'm going to start this question again. Cosecant theta equals cotan theta over sine theta. Oh, sorry, cos theta. Again, notice I'm not putting equal signs down. Because I'm working with identities, I'm not working with an equation. I'm not trying to solve anything here. All I'm trying to do is make the left side equal the right side. So I draw a line down and I don't use equals all the way through this process. So in B it says, numerically verify that if theta is equal to 45 degrees, then that's a solution for the equation. So now I'm going to switch this. I'm going to go 1 over sine 45 degrees. This guy, cos 45 degrees over sine 45 degrees over cos 45 degrees. Now, 1 over sine 45 is the same as 1 over root 2 over 2, which is equal to 2 over root 2, which I'm going to leave as is. This guy, I'm going to just write it over here. Cos 45 degrees over sine 45 degrees divided by that is the same as timesing by 1 over cos 45 degrees. Because when I multiply fractions, that's over 1. Or divide fractions, sorry. When I divide fractions, I multiply by the reciprocal. That gives me that. So what am I left with? 1 over sine 45 degrees, which is the same as 2 over root 2, and those equal each other. So I can simplify this, or I could just put values in here and then simplify it. But by putting values in, then I get a bunch of fractions, and it's not as easy to do. Okay? All right. Okay, now what I'm going to show you right now is, you know what? I don't want to do the graphing part yet. I'm going to leave the graphing part for a second. Okay. On your unit circle. So hopefully you have your unit circle out. Sine 45 degrees is root 2 over 2 and root 2 over 2. That's cos 45 degrees. That's sine 45 degrees. So substitute in, instead of sine 45 degrees, I put in 1 over root 2 over 2. And then when it's 1 over it, I just reciprocate it to get 2 over root 2. Okay, let me use working example 2 to help better explain this to you. Okay, I don't really like the way they do this first one. So let's go to working example 2 on page 190. It says determine the non-permissible value in radians of the variable in the expression, and then simplify the expression. Okay, so I have tan x cos x over secant x cotan x. All right, now it says find the non-permissible values in this. Well, tan x is sine over cos. This is 1 over cos, and cotan is cos over sine. So the denominators in all of this, and I'm going to show it to you real quick in a second here, but the The long and short of it is this. Cos x can't equal 0. Sine x cannot equal 0. All right? So if that's the case, all right, so sine x can't equal 0, cos x can't equal 0, and I want the non-permissible values. So the non-permissible values are this. X cannot equal. Well, where does cos on the unit circle? So on the unit circle, cos can't equal 0 where? Right here and right here. Sine can't equal 0, or sine equals 0 here and here. So then that tells me then that cos x can't equal 0 at pi over 2 and 3 pi over 2. And sine x cannot equal 0 at 0, pi, or every 2 pi. So every k pi. So these are my restrictions on this. All right. Now, where do I get this from? Well, let's write this out in sine and cos. So tan x is, sorry. So I substitute in there. That's times cos x. Secant x is 1 over cos x. And cotan x is cos x over sine x. Like that. Okay? So by writing these in their very base values, just sine and cos here, okay? Notice the denominator here is cos. So this guy can't equal 0 or it's undefined. The denominator right here is sine x. Undefined if that's equal to 0. So what values of x make sine x equal 0? Well, sine is 0 degrees, or sine is pi, or sine is 2 pi. I end up with 0 and 0 as my values. And I can't have that. That's an undefined value. For cos x can't equal 0 at pi over 2 and 3 pi over 2. At pi over 2, there's my cos value. At 3 pi over 2, there's my cos value. So those are my non-permissible values. Now, they want you to simplify this. Well, by simplifying, all I really want to do is take it down, basically reduce the fraction. Cancel anything that I can cancel. Well, cos x here and that cos x there, they cancel. So that leaves me a sine x on top. And on the bottom, that cos x and that cos x cancel. And on the bottom, it leaves me with 1 over sine x. All right? So now I have sine x divided by 1 over sine x. Because I'm dividing, I multiply by the reciprocal of 1 over sine x. So that gives me sine x on top times sine x over 1 on the bottom. So my final solution for this, so this whole thing simplifies down to sine squared x. That's the simplified value. And these have to be included as my restrictions. So I go comma and then write this out. X can't equal pi, so x can't equal 0, pi over 2, 1 pi, 3 pi over 2, or 2 pi, if I'm talking about that. Okay? Now, I mentioned this to you before we all split up there 2 weeks ago, that this section is going to be one that causes a lot of problems. All right, and this whole arrangement we have with doing it online is not going to make your life a whole lot easier for it. So we'll do the best that we can. We'll get through it. You'll get an understanding, a basic understanding of it, and then we'll work as best we can together through this. Okay. I'm going to look at working example 3. It says verify that the equation cotan squared x minus cos squared x is equal to 1 is true when x equals pi over 4. All right. So cotan squared x minus cosecant squared x is equal to -1. And it's asking me to verify this for when x is equal to pi over 4. So since grade 11, we've talked a lot about the unit circle and having a very good understanding of the unit circle. Okay? This is the reason why. This one section, it's so imperative that you have that unit circle beside you to answer these questions, because if you're going to consistently look up these values on the unit circle, it's going to take a lot of time, almost too much time. All right? So I've got cotan squared x minus cosecant squared x, and they want me to substitute in pi over 4 and then simplify it. So I'm again going to work on just the left side, because I take the side that has more work on it, and I want it to equal whatever's on the side that has less amount of work. So in this case, the less amount of work is -1 is -1. All right. So number 1 rule when it works with trig identities is, if you're unsure, break them down to your 3 basic identities. So, or even 2 basic identities, using sine and cos. So cotan squared x is cos squared x over sine squared x. Okay, that's what cotan squared x is. Minus 1 over sine squared x. All right. Now at this point, I could put pi over 4 into the value. I could also simplify this. You see that I have a common denominator here. So I could write this as cos squared x minus 1 all over sine squared x. Okay? So I've broken it down into just sine and cos. When you do identities, this is the one thing that is probably easiest for most, is to break it down into sine and cos, because those are the values from the unit circle that I should know. So now I put in this. I've got cos squared pi over 4, right? Yeah. Subtract 1 over sine squared pi over 4. Okay? So go to your unit circle now. All right? And what's the cos value of pi over 4? Well, it's root 2 over 2. Squared, subtract 1. And on the bottom, root 2 over 2 squared. Just going to extend the page here. Okay? On top, root 2 over 2 squared is 2 over 4, subtract 1. And on the bottom, I have root 2 over 2 squared, which is 2 over 4. Okay? Simplifying fractions, 1/2 subtract 1 is negative 1/2 on the top. So 2/4, so that's 1/2. 1/2 subtract 1 is negative 1/2. And on the bottom, I have 1/2. And when I divide them, I get negative 1, which is equal to my right-hand side. This is what we call a trig proof. A trig proof starts with your original statement with an equal sign. And then I do not use the equal sign again. Now, in the old days, we used to do geometric proofs, and you would understand this. But this is the first time you've seen what a proof is. And so what I'm trying to do is I'm trying to prove that the left side equals the right side. So to do that, I have to break it all down. So they suggest, hey, put in an actual angle and then solve it, all right, to make it work. Okay, so that's what we did. I changed this to sine and cos. So cotan squared was cos squared over sine squared. Cosecant squared is 1 over sine squared. I have a common denominator here. And then I have cos squared x subtract 1 over sine squared x. I put my pi over 4 value in. And then I have to use my unit circle and put the exact value in for it. So the cos of pi over 4 is root 2 over 2. So I substitute that in. The sine of pi over 4 is root 2 over 2. Square both those values. I end up with 2 over 4 minus 1 over 2 over 4. And when I divide them out, I end up with minus 1, which is exactly what I needed to end up with here. This is called a trig proof. Okay. You can use your calculator to graph these. You're going to have to use your conversions, substituting sine and cosine in order to graph them on your graphing calculator. Okay, the only way you can graph them is if you change them all to sine and cos. So if you're asked, I'm trying to just get this all for you. So if you're asked to graph this, y equals cosecant theta, you have to use your graphing calculator and go 1 over sine theta. All right, you can only use the sine, cos, and tan for it. I get that. Okay, so y equals 1 over sine theta. All right, this is going to be tough for you to go through, and it's going to take time. Lots of these questions take a significant amount of time to do. And if you look at 6.2, there's a lot there. Okay, so what I've been doing all day up to this point is just kind of giving you what I need to have done so the other 3 classes understand where we're at. Most importantly today is I want you to get set up on Microsoft Teams. That's the one most important thing I need you to do today. I need you to get set up on Microsoft Teams. Now, if you don't understand how to get set up on Microsoft Teams, look at my video from 9 o'clock this morning. It will give you all the explanation on how to do it and get set up. The second thing I want you to do is I need you to, if you can't get set up on the Microsoft Teams, you need to email me. I need to know where you're at. If it's working, it's not working, whatever. As well, I want that assignment in as well that I gave you before the break. The most important reason is so that I know that you have been keeping up with me as I've gone through before the break. Okay, so that's going to be important for you. The third thing I need you to do today is go through 6.1. Look, this is not going to be easy. It's going to be tough for us to to work through this when you guys are not on location, but it's just the way it's going to be for us. We have to do the best that we can and make do. I think if we can get this to work, that's going to be a life changer for all of us, because we can then become a lot more interactive. If Microsoft Teams does not work for everybody, class isn't going to start, so whatever. Okay, if we can't get set up on Microsoft Teams, we may have to look at another avenue to do it, and that would probably be Zoom. But the division wants us to try this first and see if it works. So I need you to do that. If you did not follow this morning, if you were not on at 9 o'clock, the provincial exam has been waived for this year, meaning that there is no provincial exam. One of the questions we had earlier was by June, then what I think happens is we'll have an exam in this class, okay, if we go back to school in June. If not, then what's going to happen is we're going to just continue to do assessments the same way that we've done assessments before. All right? And that is, I have to send them out to you, you have to email them back to me, and that's the only way that we can make this work. Okay? Other than that, Microsoft Teams, I think, so what's that, 11:45, 12:15. I think I set up this morning, I believe. Just let me check. Sure. Yeah, 12:45. I know it's not ideal, but I'm going to try and have a Microsoft meeting with you at 12:45 today. Okay? I reposted that assignment for you this morning. Will it be 30%? I have no idea, Brendan. You're asking questions I can't answer. I'm going to say yes. Well, Petra got it to work, so it does work. I put it on there as a PDF, so go to the PDF and pull it up. If you don't have Microsoft Word, it's probably not going to work, but you have to use the PDF. You're going to have to figure this out, Dalen. You're going to have to either get it so that it works as a PDF or find a way to get Microsoft Office through the school division. They're offering it for you. But I know when I pulled it up on my phone, it didn't work as Microsoft Word, but as a PDF or as an RTF, but as a PDF it worked. I don't understand, Rory. Microsoft Office is not letting you in what? Well, how did you do it the other day? Yeah, it is, Mary. But I got 15 minutes here before I got to try this Microsoft Teams with the grade 10. So we can figure this stuff out right now, if that's what you want to do. Okay. All right. So what part of this is not working, Rory? Yeah, that works, Daylin. Figured out, because we're going to have to do both classes like this. I know it's not ideal, but you'll have to do something. Okay, well, download the app then. I don't know what to tell you. Or get Google Chrome instead of Safari on your computer. Look in your menu on your right, or on your left, sorry, under your apps, and see if you have Google Chrome on your apps. Rory? So then go to your app store and get Google Chrome. That might be easier than that Microsoft app. Has anybody else tried to get on Microsoft Teams this morning yet? And had it work? Okay. I'm still here. I'm just trying to get some other things. Okay, I'm gonna log off on here and try and get back on at 12:45. We'll use that Microsoft Teams. Okay.